So let's look at an example. It's basically the same exact thing, kind of just done a little bit more with some numbers. This B is going to be 2 meters tall. This A is 5 meters over. This force of 200 newtons at a 3, 4, 5 Pythagorean triple. Let's find the moment about O, so M sub O. So you know I'm going to want to break it up into components. And how do we do that? We can use this force triangle. F sub x is going to be, see here, this side of the force triangle is the x, so it's going to be 4 over 5. I don't have the 5 drawn here, but it would be a 3, 4, 5 triangle, so it would be 4/5 times 200, or 160. And Fy would be the vertical side, so 3/5 times 200, or 120. So now I've got those components drawn on there. And like I've told you in the past, I like to draw my components as different looking vectors, so that way you're not going to be, I don't want to find the moment of this vector and that vector and that vector, because that's twice as much moment as we really have. So I like to keep them kind of separate. So I draw them dashed usually. But anyway, here's the fx and the fy we found in the last slide. And now we don't need to find this distance d anymore, because we just know the perpendicular distances. So the 160, its perpendicular distance is 2 meters. So x forces, in 2D, x forces are usually going to have y distances, and y forces are going to have x distances. And you'll see why when we get into the vector formulation, because it all comes out of this cross product, but I'm getting ahead of myself. We do this math here. Note the negative sign here on the 160 times 2, and that's because this is a clockwise rotation about O. Again, put your pencil tip here at O. Push along this direction right here. That would want to spin clockwise, so negative. The 120 is going to want to cause a counterclockwise rotation about O for the same reason. Put your pencil tip at O, push up on the right-hand side. It's going to cause a positive. So you end up having a negative and a positive sign here in the two terms. And you can just do the math. Minus 320 Newton meters plus 600 Newton meters is going to give me 280. So in this case, it ended up being an overall net counterclockwise moment, as kind of is visible by if you put your pencil tip at O and you push along this line of action, which is the resultant, right? So you kind of knew that going into it all along. One word of warning here: a lot of students think if the vector is positive, acting in the positive direction, that the moment's going to be positive, and that's not at all what I've been saying. I've been saying that the tendency to cause counterclockwise rotation is what makes it positive. So this force here is acting in the positive x direction, but since it's up above point O, it's causing a clockwise rotation that is negative. If it were down below point O and acting to the right like it is, it would be causing a positive rotation. So you cannot just look at the vector's direction and think you know the moment's sign. You have to look at both where it's acting relative to the point and its direction.